corrections on 5.5 trapezoid rule. So this is another method. In 5.1 we had mentioned the left-hand rectangular approximation method, which was the LRAM, and then also the RRAM, which was the right-hand rectangular approximation method. And I had stated that that wasn't the best method because we had some areas under the curve that was missing. And so I said choose something else if you could choose something else as far as the area method. So the trapezoid actually would be the next best method. If you had to choose between the LRAM and RRAM and the trapezoid probably would be the best method. So let's go into the trapezoid formula. So we still have is the integration from a to b right there, and we have is f of x. And then one of the trapezoid, because there's two trapezoid formulas, is that it's b minus a. So the b is representing from the higher limits or the upper limits right there. A is representing the lower limits right there. And then n represents the number of rectangular boxes that you have. Then notice that this part right here is times the first number plus 2 times the second number plus 2 times the third number plus 2 times the fourth number, etc. And then we have is plus the last number. So the last number and the first number is going to be itself, and then everything in the middle is going to be actually 2 times it right there. Okay, so that's one trapezoid formula right there, using all of this right there, that method. The other method is this right here, is that LRAM that we learned in 5.1 and plus RRAM that we learned in 5.1, and then we divided by 2, which means that we took actually is the average between the two LRAM and RRAM. So this is why I'm saying the trapezoid method may be the best method if you had to choose. So now let's go ahead and do an example. So if I take this equation right here, or this picture right there, and I have is this parabola right there, and I'm going to use is the intervals right here is 1, then 5 over 4, 6 over 4, 7 over 4, and then 2. So we're going to take those numbers and we're going to put it into the equation. This is a parabola equation right there. So we're going to put it into a parabola equation right there. So I'm going to take each of these numbers, put it into table format. So I have a 1 right there from this 1, 5 over 4, so that's your 5 over 4, 6 over 4, 7 over 4, 6 over 4, 7 over 4, and the 2 over 4. So if I substitute this into this equation right here, 1 squared is 1, 5 over 4 squared is 25 over 16, 6 over 4 squared is 36 over 16, 7 over 4 squared is 49 over 16, and then 2 squared is 4 right there. Okay? So we're going to take all of this, and this is the data that we're going to use for the trapezoid formula. So I'm going to do both methods so you can see how it works. So the first method is that formula part of it. So I have is then B is right there is going to be the last number right there, the bigger number for the intervals. A is going to represent the smaller number right there. The n represents against the number rectangles. So I have is 1, 2, 3, 4 rectangles, so that's the n right there. This is the first number right there. So in our case, the table says 1 is the first number. And then after that is 2 times everything in the middle, so which is all of this right here. And then plus the last number, which is this right here. Okay? So this is what it looks like. So then I have is 2 minus 1 right there, and then the 4 rectangles right there. The 1 was the first number, plus 2 times 25 over 16, right? 25 over 16, and then 2 times 36 over 10, the 36 over 10, etc., all the way up to the last number, which is 4, and that 4 by itself, okay? So that's, again, let me just approach that right there. Okay, so then I just worked with the fractions, so I simplified my fractions. The 2 and 16 goes in evenly by 8. So that's how we got this right here. And I got the 1 right there, the 4 right there, and then 2 minus 1 is 1, 2 times 4 is 8. That's how we got this. So we could just simplify it further on this fraction right there, and that gave us 150 over 8, the common denominator. So then from here, I multiply those guys together. That gives us 150 over 64, and then I divide it out, and we got a decimal of 2.3475 right there. Okay? So that's one method, which was that trapezoid method. The other method we mentioned was the LRAM, RRAM divided by 2. So doing the LRAM, which we did in 5.1, we start from the left side, which is this part right here, right? We start from the left side. We omit the last number right here, and it's base times height right there. So the base right here, this gets a little tricky. It's between 1 and 5 over 4, which is about 1/4 is the length right there. So same thing, if I take 5 over 4 and 6 over 4, if I subtract that, it's 1/4 right there. So the base right there is 1/4, and then I take each of those numbers right there. So I take 1, 5 over 4, 6 over 4, 7 over 4, which is all of this right here, right? But I squared it. So 1 plus 25 over 16 36 over 16, 49 over 16, which was all of these numbers that we had up here. And we just omit this last part for the LRAM part of it. So that's this part right here. Okay? So then from there, I just simplified it, 126 over 16, and then I worked that out to 126 over 64 right there. Now we go the other direction, which is RRAM. So RRAM now, we go from the right-hand side. So we go from here, and we omit the last number, which is in this case is 1. So then we go from here, 1/4 still is the base. So we go from 4, so that's 4 right there, 49 over 16, 49 over 16, 36 over 16, 36 over 16 plus 25 over 16. We simplify that. That gives us 164 over 16. And then we simplify that further, 174 over 64. So the trapezoid rule says now I take both of the LRAM, RRAM divided by 2. So we're going to take both of this right here, the 126 over 64, 174 over 64. We're going to add those together and then divide it by 2. And then if you work it out on the calculator, it comes out to 2.34375, which was exactly the same as this right here. Okay, so both methods, let me show the focus out here. So both methods should give us exactly the same answers. It's just depending on preference. Do you prefer to put it into the formula, which was example 1 right here, and just substitute it in all and then work it out? Or do you prefer doing the LRAM, RRAM, and then basically taking the average of those? Okay, so that's the trapezoid method that we're going to work on now.